Welcome to the AI for You Cafe for live presentations around AI. Today's live presentation is themed, How is AI helping companies to deal with massive admin workloads? So I'm very happy that you come here today. I have with me Gonzalo and Azure and Miguel Garcia from the company Bosonit. I will rehearse the names, but you also can see them in the screen. Very happy you're here today. This is the session before my summer break, of your summer break also. So my name is Cam McWilliams, and I'm the moderator and organizer. I'm the director of the company Grassroots Arts and partner in European AI for You project. Please take notice that this session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for You project opinion. So again, what is this cafe about? I think this is now 1 year of cafe, but important is the cafe is open. It is an online forum to gain insight into the European AI scene. Participants get the chance to share knowledge and experiences and meet stakeholders from various areas of AI. This is also a matching platform, a possibility to afterwards connect to the speakers, and so it's an open forum. And I now have the pleasure to introduce Gonzalo and his CV. This is Gonzalo. Hi, Gonzalo.
Hi.
Hi.
Hi, everyone.
Data scientist for banking sector at Bosonit. He has this bachelor's in physics at University of Zaragoza and currently studying a master's in artificial intelligence at UNID. He has an experience of around 3 years in IT innovative projects, working with banking and insurance leading companies, most of them oriented to help clients with digital transformation. Having worked for Big Fours during 2 years, for the last year and a half, he has been working at Bosonit as a data scientist involved in the maintenance and improvement of a cognitive platform that processes and extracts information from the document needed for mortgage granting, automating the workflow. Great to have you here. And I know that you will be the speaker, the second speaker. So now we come to the first speaker today, to Miguel. Hi, Miguel. Good to see you.
Hello, everybody.
I'm also introducing you. Miguel is Director of Innovation at Bosonit, being industrial organization and BCI computing at University of Deusto. So Bachelor of Engineering, Industrial Organization, and Bachelor of Science Computing at University of Deusto. Sorry. He has an experience of over 10 years in R&D projects through a number of H2020 and FP7 projects. He has coordinated 4 projects, Fireware, Finodex, Ilsus, Blockshares, and Data Market Services in the last years. All of them oriented to support startups and entrepreneurs working in the fields of data and blockchain. He has recently joined Bosonit after working at an innovation consultancy firm, Zabala, for 10 years and previously 2 years at SAP. So this is all impressive. Thank you. Hello, Miguel.
Thank you very much.
Good to
nice
see
you.
All. In the cafe. And I'm now making you the moderator, as Gonzalo comes afterwards. But before you start, dear participants, I'm happy you're here, and use the chance to ask questions to the speakers. There is on the right side the control panel. Use it, write your questions down, and I will read them after the presentations to the speakers, and if the time allows, they will answer. So now again, to you, Miguel, the floor is yours. You can now take over.
Thank you very much for the nice presentation, Carmen. And thank you everybody for joining us this afternoon at the AI for EU web cafe session. For us, it's a real pleasure to introduce our company here. So today we're going to talk about how AI is helping companies to deal with massive admin workloads. And we are going to present a practical use case that Gonzalo, my colleague, is currently working on a bank company here here in Spain. But before we go into the details on the AI and the technicalities of the project, I would like to also introduce a little bit the company, Bosonit, the group we are part of, and why we are actually here. So Bosonit is a company which is part of a major consultancy group called NFQ Group. NFQ Group is a global consultancy oriented to the financial sector, which counts with presence in 17 countries, over 100 global customers, and over 1,000 employees all over the world. We offer an end-to-end flexible and specialized model of consultancy in which we provide services from a business perspective, but also from an IT approach. And this is where we at Bosonit stand for, the IT approach. Our main specialization or business lines within the group are mainly four, although we also participate as investors in other startups and other companies, mainly in Spain, but also in South America. We have NFQ business line, which is the functional knowledge. We have the process subsidiary, which is Enforce. And then we have the technology arm of the company, which are Bosonit and Enter. Both of them are companies originally from Logroño in Spain, although we are also expanding inside the country and outside. Bosonit is specialized in data and obviously all what is related to data, and this is our relation to artificial intelligence. And Enter is more focused on technology, DevOps, developing skills, and so on, so that we can complement each other whenever the NFQ group goes into a project. The way we do this is through what we call the nearshoring approach. So this is how we on our commercial activities operate. We offer a hybrid model of consultancy, providing resources on-site and off-site. You have some stats there about the number of hours we've developed this type of approach in the past years. Just to mention, Bosonit counts only with 5 years of existence. Enter was created afterwards, even in 2017. So we are very young companies, but scaling up really, really fast. And with the acquisition of NFQ, even farther. Our presence in Spain is through different office sites. As you can see on the map, we are present in many places and growing a lot. And this is a little bit the procedures when we talk about the commercial capacities that we have. Talking about Bosonit as such and as a database company, we divide our areas of specialization in these 5 groups you can see on the slide. We work on data management, we work on big data, data visualization, artificial intelligence, and we have also emerging technologies, so or which is related to data but not strictly data such is categorized there, and this is where some of our innovation activities go there. We have expertise in many technologies which we apply depending on the type of product, the requirements of the customers, and the needs. And this is why we are very, let's say, horizontal in the sense of the type of projects we can undertake, the type of technologies we can apply, and so on. Talking about our customers, we have major presence in the banking and financial sector, with 50% of our income coming from this sector, but also we operate in combination with other IT companies. Also, we do have projects in insurance as one of the major sectors we operate. And then of interest are also the tourism sector, pharma, public sector contracts, real estate, and industry activities. And talking about the innovation, which is the part that I'm currently leading, we have to say that although we have a moderate presence in European projects, we are expanding so far. And the good thing about us is that we are really focused on very proactive innovation, in the sense that all our activities in R&D are oriented to create and generate new products. So this has been like that since the very roots of the company, since it was created. And we've been awarded with different regional grants. As you can see, 16 projects since 2017, which has helped us very, very much to develop new products as the one that will be converted into a spin-out during this quarter, which is Elliot Cloud. Elliot Cloud will be born as an industrial IoT platform in the coming months. So we're now in the process of setting up the company and so on. And it will be the first spin-out that we launch. And it will be thanks to the participation in a number of innovation activities and so on. So this is one of the major milestones that the company has achieved so far in terms of innovation. At the same time, our investment since 2017 in R&D, being a company which was created in 2015, is significant. So next year, we even expect to reach the 3 million. So I hope that we can collaborate with you in the coming months in the New Horizon Europe or in any initiatives you may have there. At the same time, we've been awarded with different projects, more traditional ones from the Excel perspective, like the Productive 4.0 or the Azure Cloud, but also we've been granted with some experiments in cascade funding schemes like Select for Cities, L4MS, or DAH Square. And this has been so far our activities. Said that, I would like now to give a little bit the floor to my colleague Gonzalo, which will go into the details on how we are working actually with the banking industry on automatic document processing. Thank you very much. And now Gonzalo will stop sharing and we'll leave you.
I have now switched the moderator to Gonzalez. Yes.
Okay.
Gonzalez.
Okay. So I see now you can see my screen. Okay.
Yes.
So
Yes.
I hope you can hear me well. So
I hear you. I see you. Perfect.
Okay. Thank you. So thank you everyone for joining in this web cafe or this webinar today, and moreover being the 16th of July, which in a day everyone is waiting for summer break and all that. So I hope you have a good time here during this presentation. Okay.
Yes.
So I will skip this part of presenting myself as Carmen has already presented me. And first of all, I would like to talk about why did we decide to make this, or to make this talk. Okay. We think many times artificial intelligence and machine learning pipelines are seen like independent pipelines, or maybe at the very end of a process, and without interacting with other parts of the business processes. Okay, and even more if in a research and development company or a research and development project in which maybe the main goal is not that bringing that idea to real life or to a production environment, but only like research that idea. Okay, so now we are going to present what we think is a very interesting project. Okay, that it was applied in, or is currently being applied in a traditional bank. Okay, so not a recently created company. That means that the business processes it affects or were already designed or were already working when the project started. Okay, that's why we think that this talk is interesting. We think that, or from our point of view, it's pretty difficult for a traditional company to start using AI, and many companies struggle with this task. And we want to present like a real world use case. Okay, we are going to, as I have said, we are going to talk about a project that is valid for, or was applied in a bank, in the credit part of the bank, the credit department. Okay, and that's all the introduction of this part of the talk. Okay, so why is document processing important in a bank? Okay, banks are, and more from 2008, banks are very regulated companies, are or very different to other types of companies where everything can or the companies are more free to operate the way they want. Here, banks are very regulated and have strict regulations, and that means that almost everything you do in a bank has associated a document that gives you authorizes the bank to do that. Okay, so if we talk about the credit department of a bank, they need a lot of information about the client in order to take that decision. I mean, when somebody or a company goes to a bank to ask for money to do some project or to buy a house and all that, and the bank needs to assess the financial position of that person in order to decide whether it's a good idea or not to give that person the money. And that means that the client has to hand over several documents so that the bank can assess that situation. Okay, and then there are previous. And this is the example we are going to talk about. Okay, the process of clients giving documents to the bank so that they can assess their financial position. And specifically, we will talk about the process that is after the client goes to the office and before the scoring department rates that client. Okay, so what we are going to do is trying to take all that information, collect all that information from the documents the client has given us. Talking about why is this interesting? This was a pipeline that until some years ago was being made by real people who looked at those documents and scanned them and decided if they were valid documents or not. Okay. And now we have this pipeline is automatic, and sometimes a person has to do the job if the process cannot decide if whether the document is valid or not. Okay, so here I have also introduced the concept of a valid document or not. And what do I mean by a valid document? And why do I say this? Because this talk will go about a platform that is able to validate and extract information from documents. Okay, so validating a document, for example, a payslip from a person, is trying to check if the document meets all the requirements a payslip must accomplish. Okay, so it has to be from the person that is asking for the money, for example. It has to meet certain requirements. For example, it has to be from the last 3 months or 6 months. It has to be from the company must be informed, the salary must be informed. There are certain checks the document has to pass in order to be validated. Okay. As you can imagine, there are many types of documents that can be processed in this pipeline, and are very different if we talk about natural persons or about legal persons. Okay, natural persons have their own documents, like natural person belongings declaration, that is like the main document where is not a standard document, but a document that the bank creates to try to get all the information, and then the others what do is justify that the information you put before. For example, in a NPBD, you say that you work for a company and your salary is 1,000 euros a month, and then you have to attach also a payslip that says that that's the money you earn each month. Okay, so we'll present only an example. This pipeline is a little bit more complex when you introduce that different documents, or all those different documents, and we'll talk about a specific one. But I think it's enough to understand the pipeline and all that, and how the pipeline was implemented. Okay, so now we are going to see the architecture of this process. Okay, how is this process designed and how it works in terms of architecture. Okay, so here first we have like the bank office, okay, where a client goes and hands over their documents. This can be also a person in his house with his smartphone, and when that's the point where the document enters the pipeline. Okay. Yeah. As you can imagine, in a bank there are different or many different types of documents, and we only process some types. Okay, like around 13 types, and maybe there are 30 types of documents. So there is a first piece that decides whether we have to process that document or not. For example, if it's a payslip, we will receive that document. Okay, so that distributor will make a call to our API service, and the API, here we can control if we process a certain document or not. Okay, and it's introduced in the pipeline itself. Okay, for you to understand a little bit more the diagram, okay, these objects right here are Kafka queues. Okay, so act as queues for the messages we have to process. I will talk more about it later, but and these rectangles are the different services the pipeline has. Okay, so are implemented in the way of a Docker container. Okay, so that this microservice architecture allows us to scale very quickly, depending on the needings of the platform. Okay, and here we have a Mongo database. And okay, so this is to understand the diagram. I'm going to talk now about the process itself. When a message enters, it has some metadata from the office, for example, who is hanging that document over, or the date, the office, and all that, and that enters to a queue. Okay, and that queue stores all the messages to be processed. Okay, so this allows us to have more documents that simultaneous processing containers. Okay, now the enhancement part of the enhancement service, what it does is receives the information and the original document from the client and saves that document in the Mongo database using a document API as a proxy, so that if this piece changes in the future, we can change only this and the way this interacts with with, in this case, Mongo, so that all the pieces that use it don't need to change anything. Okay, and after saving the document, it also calls Azure OCR, okay, the Azure Read service that is available in our case in Spanish. That is the language that applies most of the time in our platform. And we process the whole document, okay? And also we generate with image we try to process the document so that we end up with some images to process, and we, for example, we rotate the document if it has been scanned wrong and all that. Okay, and after the document has been enhanced and we have the readings stored in the MongoDB and all the images in the Mongo, we call the next service. Okay, well, these three in the bottom are the services we'll talk more about later in detail. Okay, we have another Kafka queue so that these messages can be stored here and being processed one by one by the classification service. And the classification service tries to guess which type of document are we dealing with. Okay. After we have the document type with all the images processed and all that, we extract the information, we validate the information, and assess that it meets the requirements, and then we make a callback to the distributor. So with our response, for example, valid or not valid, and back to the office or to the user. Okay. And then all this information, there is another pipeline or business process that we won't talk about, that when it has all this information is stored in a recording context, and then the next department works with this context and tries to score and decide whether the loan should be approved or not. Okay. And here all the process is orchestrated by a JVPM. Okay, so that we can follow its task and where it's going by. Of course, there's an error management system between here or orchestrating all this. But we don't show it for simplicity, but I hope you can understand the basics of the pipeline. Okay. So here we talk about the classification pipeline, okay, and the main features of the pipeline is that it works a little bit different for digital and scan docs, okay, documents, because there are, oh, sorry. Okay, no, I was reading a message that I didn't have, I wasn't controlling that part, but it's all the welcome message. Okay, sorry. So we have, as I was saying, we have slightly different pipelines for digital and scan docs. And by digital, I mean that the documents that are not, for example, your digital payslip that you don't have scanned, but a document that is created by the bank, like the NP, like the Natural Person Belongings Declaration, that is a specific document from the bank that you can fill with, and it has a specific template, and the pipeline is a little bit different. So the documents go by in another pipeline, and we will talk about the scanned documents, okay? And digital documents that are treated the same, okay? So what we do for in this classification pipeline is retrieve that Azure OCR readings, and the output will be one prediction for each page. Okay, not the output, but the classification stage will classify each page or each image, and we have more classes than types of documents. Okay, and that we'll see later why this is important. We only use the images, as I have said, so we have a more flexible pipeline because we can treat PDFs, JPEGs, TIFF images, and all that in the same pipeline. And in the future, if we develop a tool that help us transform Word documents, for example, to images, the process will be the same. Okay, so this makes the system a very flexible one. And in total, we have around 23 classes. Okay, that, as I have said, are more than the number of documents, of different documents we process. Okay, so, well, and when this is, now I'm going to explain the pipeline for each image, okay? When we have an image that we have retrieved from the API and the Azure readings associated to that image. And first of all, to classify it, we make a feature engineering step, okay? So we have those two origins or those two information pieces, the OCR and the image, and we'll use them separately and then join it to make the model that classifies the document, okay? So first, with the OCR, we make a TF-IDF model, okay, with max features as a hyperparameter adjusted during training. And we use, with the image, we use a mobile net without the last layer so that we can end up with an image embedding. And as it has a lot of features, like 1,000 features, we use a PCA model to select around 100 of them, okay? And after we have those two origins or those two feature origins, we mix them and we use a multinomial logistic regression, okay, algorithm. So why such a simple model in the end? Because as you can imagine, having annotated documents page by page is very expensive in terms of time, and there's a department that has to be working on that, okay? So the number of documents we had to train the models was not very large, so we had to use a relatively simple model that, as you can see in the KPIs, performs very well. So we don't need any more complex model. Okay, as I have said, this pipeline is made or is executed for each page of the document. Okay. And for example, payslips, at least in Spain, are usually one-page documents. But for example, income tax document can have more than one page. So we have a segmentor, okay, that tries to aggregate those pages to create single documents. Okay, so we have, for example, there can be a document or that it has always a front page, intermediate page, and a back page. Okay, the segmentor uses heuristics to try to say, okay, if I have a front page and then I have classified 3 pages and 1 back page, we can I can say that these 5 pages are 1 document, okay, and aggregates that. So if it can receive a document containing many more documents inside, and will separate that and output that as different messages to the Kafka queues. So those messages will be extracted separately. Okay, the extraction pipeline for each type of document is slightly different. So we want, for example, if we have 2 payslips, those payslips are processed separately, and then if we have another type of document, also to their type of containers. Okay, so that here, when we talked about the architecture, we said that we could scale as we have a microservice architecture. For example, if we have many more payslips than NP personal belongings document, we can have many more containers extracting payslips that extracting other types of documents. Okay, or if we have a lot of documents to be classified, and then we have that part of the process is very slower, we can have many more containers working on those documents. Okay, so after the classification step, as we have seen before, comes the extraction step. Okay, so now we are going to use a pipeline for a payslip. Okay, so imagine we have ended up with a payslip classified document for the original document from the client. As I have said, we have different Docker images for each extraction service, and this gives us more adaptability to load changes, and we can balance that load perfectly, and are managed from by Kafka groups. Okay, so we have a message goes to all the containers, and the container decide whether they have to process that document or not. Okay, and as you can imagine, the extraction needings for each document are different. So this is a stage where that takes place in the designing stage of the project. Okay, and what we see is, for example, for a payslip, which fields have to be extracted and are needed by later processes. Okay, so as you can imagine, the worker name is important, the worker ID, the company name, the salary, and maybe as I have said, the ID of the worker. And for example, from a contract, if you have a job contract, okay, you may want to extract also the company, the worker, but also the duration, if it's currently active, that contract or not. Okay, so different documents, different needings, and we can adapt to all that. Okay, and the output is a JSON document also with all the capabilities that have been extracted. Okay, maybe sometimes I will talk about capabilities, and this means a field that is extracted is how we call it in our project. So sometimes I will say that. Okay. Now we are going to see the pipeline itself. Okay. And first of all, a key step in this pipeline is when we try to infer the layout of a document. Okay. So what happens? Well, as you can see, all this data is mocked. Okay, I am the worker, and I work for the European Union and all that, so all the numbers are mocked, so no personal data is being shown. But payslips, for example, are, or at least in Spain, are not standard documents that the government tells you how they have to be, or a template, but the company designs, we could say design, the payslip document. Okay, so what does this mean? This means that the information can be in different places depending on the company that has issued that payslip. Okay, so we cannot search in some parts of the document for some information because we don't know where is it going to be. Okay, for example, there are other documents that are standard, and we know where to look for something because we know the place where it's going to be more or less relative to the margins of the document. Okay, So first of all, we try to infer the layout, okay? And by the layout, I mean the structure and the structure of the document in terms of elements that constitute it, okay? So for example, tables, text, dots, hyphens, checkboxes are also very important, not in payslips, but in other documents, okay? So we have to be able to identify these elements in the document. First of all, to detect text and tables, we use a computer vision pipeline, trying to see where do we see lines, for example, in the document, and where do they intersect, so that we can say that this is a table and all that. Okay, and also there is another strategy for detecting, for example, hyphens, dots, and checkboxes, that we have like a collection of samples of checkboxes, and we try to look for that pattern inside the document. Okay, and in the end, we end up with a pandas data frame with all this information, and we also have information about the type, but also about the hierarchy of that element inside the document. For example, if some text is inside a table or not. Okay, this is, as you can imagine, this is pretty important later to try to search for all the capabilities. Okay, so now this is the result when we use the layout pipeline. So as you can see in blue, we can see the tables that have been identified in the document, all the text boxes, okay, and dots. And in this case, there are no more elements. So we can, the hyphens and all that would show in another color, but now in this document there are not. For example, well, here you can see some dots about the next to the Swift code. And as you can see, some boxes should be merged to have all the information from that field. Okay, so that's a problem we will address later in the pipeline. Now we are going to show the extraction of a payslip document. Okay, as I have said, this document has not a fixed structure, and this is a characteristic of this type of document. And some fields are present in the document, and some others are not. Okay, so we can be looking for information that has to be in there, but other information maybe we only want to extract it if it's present. Okay, so now we are going to see the pipeline steps. We start with this payslip, like without any information about it, this image, and as we have said, first we detect the layout. Okay, so we end up with something like this, not in an image format, but in a data frame format, but something like this, where we have information about the layout of the document and the structure, its structure. Okay, so first of all, what we do is try to search for key bounding boxes. Okay, and by key I mean, for example, if we are searching for we are looking for the name of the company. Well, empresa means company in Spanish. Okay, so here the key of the company capability would be company, and the value would be the real name of the company. Okay, so for example, in this case, worker, the key of worker would be trabajador, and the value would be my name, Gonzalo Izaguirre. Okay, so this is the strategy we follow. First, we look for the keys, and then we look for the values associated with those keys. Okay. So when we predict the bounding boxes, we use information where, well, there are two strategies to predict these bounding boxes. Okay. So maybe the company ID, okay, the NIF is always the same name. So if we find that in the document, we will use that. Okay. But for the others, we use the topological information the layout has given us. Okay. For example, whether this is inside a box or not, where is the position of this part. But as I have said, this structure is not fixed, so the topological information is not enough in many cases to decide whether a key is correct or not. So here we use also a TF-IDF model, okay, so that we can see the content of that key and try to decide if it's correct or not. Okay, so with this information, the topological information, okay, for example, the position, the centroid of that box, the centroid relative to its parent element, the type of element. We join that with the text that it contains, and we use a random forest classifier to try to classify, and each box we give the probability of being a key for a capability, okay? And then we take the most probable element for each capability, okay? So we will end up with something like this, okay? This is the key for the company ID, this is the key for the company name, the worker name, the turner, the worker ID, the days the payslip is addressing, the period, and all that, okay? This is like gross amount, the tax you have to pay, and the net amount, or the after tax, okay? So that we can check that all these three numbers sum up to the same, okay? So we have the keys, and we have to suppose that those keys are correct, okay? And then we are going to try to get the values associated with that, okay? What we do is we use here, topological information is much more relevant because usually values are next to the keys, okay? So for example, if we have this box, we can see, okay, if it's more or less in the same column or it's in the same line and it's near and all that, we can say that, well, this is a pretty, this can be the value associated with this key, okay? So we do that model already also with a random forest classifier, okay? And we end up with something like this that would be, well, here we have candidates for each capability, okay? But here we are showing the most probable ones. And as you can see, we have now some problems related with the layout, and that this was not a whole text box, but was separated by these elements, okay? So we make the next step is trying to merge these boxes the layout has detected and use again our value model so that we can get the whole value, okay? For example, here we only have the whole numbers and not the decimal point or the decimal numbers. And then we repeat that process, we merge, and then we use again the value model, and we have now this is what we have detected as values, okay? So to try to have a much better information about what it contains, we crop that part of the images and send them back to Azure OCR, only that part, so that it can be read a little bit better, okay? We also select values using the metadata. For example, if the bank has told us that the payslip is from a worker called Gonzalo Izaguirre, if we find that string inside the document, we'll say, okay, this is the value. We don't have to look for this because we have found that the information given by the bank is present in the document. Okay. Then we have another step that is key for the later processes, that is generate a confidence of this extraction. Okay. So what we do is we have a lot of well, not a lot of, but some documents that have been tagged or labeled by people, and we can check, for example, based on certain conditions, for example, from the value model, if, for example, we have a date here, the format of this field has the format of a date. Yes. The score in the value model is pretty high. Yes. So we can do a bootstrap process to generate this confidence and try and say, for example, we are 99% sure that this field has been extracted right. Okay. This is, we are now working in this part, trying to get a slightly better model, but this works pretty well, okay? And we have like around a 97% accuracy in each field extracted. So 99% of the documents have all, or the fields we extract, 99% of the times it's correct, okay? And we finally output the format so that the next steps can read that information. For example, formatting all the dates, all the decimal or all the numbers so that it has no separators in the thousand. No, it has no thousand separator and all that. And then we send that message to the next step that is pretty simple, but we'll talk about it. That is the validation stage. So right now we have information about we have the information that was in the document extracted, okay? And now we have to validate that document. That is the key part, but is once you have that information extracted, it's pretty simple. Okay, so for example, for a payslip, as I was saying in the beginning of the talk, we have some rules that have to be accomplished in order to a document for being valid. Okay, so it has to be the period of that payslip has to be informed and less than 3 months, or for example, the person has to be informed and is similar to the metadata that was sent by the office. The salary is informed and the company is informed. Okay, so the rest of the fields extracted are important but are not key to say that a payslip is valid. So what we do is we have like a rules engine named rules. It's a commercial tool. Okay, now we have implemented all these rules, and based on the confidence of the extraction and the value extracted, it decides if all the rules are correct or not. And it transforms that rules to messages that the office can read. For example, if the period is 4 months, it will say to the office, wrong rule, the period has to be less than 3 months and all that, so that the office knows why that document hasn't been validated. Okay, and this is more or less all the pipeline we wanted to talk you. So we have seen from here, from the beginning, all the steps of this pipeline. Okay. Oops. So we have talked in detail about all these processes that are interconnected by a Kafka queue, as I have said, and this is more or less all we wanted to talk to you about in this talk. So now, if we will have like a questions and answer part,
Yes.
So feel free to ask whatever you want. Okay.
Yes. Thank you very much, Gonzalo and Miguel.
You're welcome.
Very interesting. Thank you very much. And I right away start with my first. I have 2 questions. First one is very simple. Will this presentation be available for the audience afterwards?
Yes.
Yes. So please send it to me afterwards because I got requests for this. So send it to me. I can send you the email. You can choose as you like, but please share the presentation. Secondly, I'm just like very selfish. I'm a small SME here in Germany. My company is Grassroots. Do you think I could already apply this service and the software to make my taxes?
That is a good question, actually. I think that that we're currently working with major corporations because the fact of these tools should be made available with when massive amounts of data exist. So you could be the user of this technology from your company. You go to a bank to ask for a credit. Yes. Obviously, it would depend a lot on the SME business. If it could make sense to have these as a service or not. I think that SMEs mostly may be users, depending on the sector, right? So if you're talking about other sectors, I'm pretty sure that in part of the audiences could be perfect technology providers of this technology as well. But it depends a lot of the type of SME you are.
Yeah. So may I just, the last question to this, I think you're really, I mean, you said very clearly you're research and innovation oriented. And so it's basically what you have 2 things, like one's a use case, is this right? A good use case, so you could be part in bigger AI projects and big data projects. That's one thing I understand, is that right? Yeah. And the other thing is you are mainly in the moment having banks, no? That's your customer, no? I mean, That's
yeah. In this example, it is. But we are also working on other projects in industry based on image recognition. But there are more, let's say, not for documents, but on image recognition for quality purposes and things like that.
Mm-hmm. Yes. Okay, now as time is running, I'm now asking questions from, I always have questions, but the others also. How many, here, Javier Gamazo, how many documents did you use to train the model?
Okay, so this is the problem is that we have to annotate or to label all those documents by hand. So this is we made like the minimum documents we could tag, so that the precision was above the threshold we needed, and we use like around 400 documents for each type. Okay, so some people of the team were checking all the fields in the document and saying if the extraction was correct or not, and that was used to train our key and value models.
Okay. Okay, and then here comes Natalie Saint-Pierre. With respect to your innovations, are you ensuring that their impact is good for people and planet? More specifically, are you using technology enabling the gathering of data aligned to UN Agenda 2030 and the 17 SDGs, Sustainable Development Goals?
Actually, I may answer that. The whole process and the whole idea of using these automatic technologies is avoiding mainly the use of paper. So there is a significant reduction there, and this is perfectly aligned. When working to major corporates like banks, they have their own policies on social responsible activities related to the process gathering of all aspects you can imagine in a bank. So all the projects that we run into are accomplishing this matter.
Yes, okay, thank you. I mean, I think it's a little bit about what Natalie was talking about this also, no? High level expert group, artificial intelligence, trustworthy AI. It's a big work of the Commission and this expert group. What I'm basically would like to know, as SMEs in a moment, you said it yourself, are difficult to get to use the AI software tools, for example, also on the AI for You platform. What, in your eyes, is needed to get more SMEs involved?
Yeah, that's a nice question. As end users, I would say there are different aspects. I would say
yes,
the first thing is AI to work. This is like the chicken and egg issue that's been for years in AI, which is the quality of the data. Doesn't matter how happy you are about using AI if you don't have enough data or enough quality data. This is the typical approach of the garbage in, garbage out. So all you need is a good and solid strategy on data management. So as such, as a user, you can use the available technologies. There is a lot of open source software already in the market. I think also A4EU is putting up a platform with a number of open source solutions that will be made available to SMEs and so on. But I think that one of the key elements in this whole AI technology thing is the data management, which is something that people tend to forget. And I say this because in our projects, we sometimes see from industry players and so on that they want to implement machine learning algorithms or many other technologies, and they don't have whether enough data so that there are significant results, or that they have enough data but it's not in a good quality. So data management strategies are really one of the key elements. So one of the things they need is data in a good way. So, and the second, obviously, it's investment. So I think that especially for smaller players, when going into the cloud may seem a good solution, it's not always as cheap as one can imagine. So investment in that field, it is really an initiative, or is something that can leverage the impact in SMEs. So data and funding, basically.
Yes, Okay. Yes, I agree. And here comes a question of Nuria Vialas. On that Payslip example, how is it possible to decide that the value of found keys under the key and not a site, for example? Shall I repeat?
Okay, no. It's a matter of training and the information we have about the content of that field. Okay, so we mix the information containing that field with the topological information about its relation with the key, and we train a model just for that, to try to get. I mean, we don't search around trying to look for boxes, but the boxes we have already identified we passed them by a value model, and it gives a probability for each of the boxes, gives them a probability of being the value for that key. Okay, so in the end we keep the most probable one. We can never say that it's 100% correct, but we have a high precision at determining it.
Okay, I think that's very clear. So, what do I do here? I am now ending for today because we are going to the end, and I have to announce to all my great participants and audience that I make this big holiday. It's really important for me because I need you back in September. So I'm not gone. We are not gone. We are all there. If you have direct questions to Miguel and Gonzalo, as I say, write it to me. I forward it. I connect you, or directly write to them as you like. You have information in the invitation how to reach them. So the information, this is a matching place here. So if you need to direct contact them, please do it. And I must again thank you. And the next one will be on September 16th. This is really long. That means like we're 2 months not meeting. But I'm starting already beginning of September to prepare everything. The next season means we're trying every week to do this cafe, so you get a full program. And the first one who breaks the ice will be Wouter. He's Wouter Denaya. He's the Chief Technical Officer of IBM in Belgium. He starts with his ice-breaking theme, The Future of AI. Then the next fall will go in different branches of AI. Always feel free to be a speaker here. Suggest yourself or somebody you really like and impressed by. And I will then get your application, and if it's good, then I will welcome you. I love to welcome you here. And then this is the most important slide. Maybe it comes, maybe not. Oh no, it means holiday. It's black. So it means like we are blocking out. And once more, I think this is really nice that you are here. For me, Miguel, I know you a little bit longer from my my work in the Horizon 2020 European Research Program. I think your use case is super great, and I hope people take the chance to to include it in their next proposals and ideas, and as we need real hands-on examples. And we discussed before, I mean, we both were also in Fireware, we both were accelerators in projects. It's very important to get good examples and also good SMEs and involved, and also good use cases. So I can only promote this more.
Thank you very much, Carmen.
Yes, so thank you. And
thank you. Nice thank you, everyone.
Afternoon, and bye-bye.
Bye, take care. Good holidays, everyone.